Okay, so third grade. Before you learn how to divide, what do you learn how to do? Multiply. Okay. So before we learn how to divide, we multiply. Okay. Yesterday we were multiplying, right? So today we're going to divide. Okay. With polynomials. So it's a little bit. The process is division, but it's not. Or I know you want to do long division in that process, but
no, I know. I'm okay.
So yesterday we were multiplying like a binomial times a binomial, right? Okay, doing that FOIL technique. Today we're going to do division, which is the reverse of FOILing. Okay, which if FOILing is just multiplication, then the reverse of that must be division. Does that make sense? Okay, so we use some terminology that is not the same as what we learned in second, third grade with multiplication, division. Yesterday we called it FOILing. Okay, today when we divide, we're calling it factoring. Okay, now think about this. If I ask you to, you guys remember back to third grade?
Yeah, I remember that.
Okay, which time?
Third grade.
Huh? Which time you did third grade? If I have 2 times 7,
14.
that gives you 14. What did you call 14?
Call it 14. The answer.
Clear on the right track.
Even number.
Start with a P.
Even number.
It's the product.
Product.
The protract.
Okay.
That's what I was gonna say.
What are these two things that multiply together to give me my product?
Factors.
Those are factors. Okay? So the individual things that we get when we multiply, or that we have when we multiply them together are called the factors. Multiply together, give me 14. So if I give you 14 and I tell you to divide it by 2, does that give you one of your factors? Does that make sense? So when I ask you to factor something, ultimately what it means is you're finding the things that divide it evenly, right? When I say divide evenly, it means there's no decimal portions. Okay? So factoring, okay, is what we're going to do today with our polynomials. Okay? So yesterday, we just go back real quick. Yesterday we were generating things like, in this example, 6x squared minus 2x minus 28, right? We're going to start now on the road to being able to reverse this, to be able to start with that, and then turn it in to that 2x plus 4 times 3x minus 7. That's our goal. It'll take several days to get there, but that's our plan. Okay? So when we work with factoring, there's several different types of expressions that we factor. Okay, and if we're talking about quadratic expression, okay, it's always going to be of the form ax squared plus bx plus c. There's always going to be 3 terms. First one's always going to be x squared. Second one's always going to be x to the first. Third one's always a constant. The ones that we're going to talk about today is when this number out here, this coefficient for x squared is a 1. Okay. That is the easiest version of quadratics, and then we'll say, okay, once we get that hammered out, what do we do when that becomes a 2, it becomes a 3, and a 4, and so forth. Okay, so just some key concepts. We've been working with multiplying binomials. Okay, in the previous section, this will be taking that product and working backwards. Okay, it's the reverse. So if we're doing multiplication, what we're going to do here is division, but it's called factoring. Okay. If we remember, we were given like something like x plus 2 times x plus 3. And yesterday we learned, but revisited that product is x squared plus 5x plus 6, right? Today, we start with x squared plus 5x plus 6. And we're going to determine those two things. Is that okay with everybody? Okay. It says this process called factoring. This is, however, if you notice that what we have been doing, we're distributing it as just multiplication. The reverse of multiplication is division. So factoring is the same as dividing. And this gives you another example that I use the 14, but this uses an example of 12, okay? All right. If we take, so let's go here. Let's say that we have x plus 2 times x plus 3. Let's go through what we did yesterday with this example, okay? Yesterday we distributed, right, or FOILed. So what am I going to do with that x? Okay, so x times x and x times 3, right? So I have x squared plus 3x, right? Okay, and what'd you do with the 2? 2x. And then 2 times 3 gave you 6. Okay, so the next thing then that you did was you looked at these two things and you combined them, right? Okay, now I'm going to do this real quick. I'm going to say this is x squared plus, could you guys agree with me that I can take an x out of these two things? And that would leave me with 3 plus 2. And then I have 6. Does that make sense? Okay. Now what's that 3 plus 2 actually turn into? 5. So I'm going to rewrite this as x squared plus 5x plus 6. Now, normally you probably wouldn't do this step right here, but I'm trying to develop some information here that we can make a connection with the pattern that I'm going to show you here in a moment. Okay. The next one. You're going to take x times x and get x squared, right? You're going to take x times 5 and get 5x. So that's those two multiplied. Now you're going to do the same thing with 4, right? 4 times x and 4 times 5. These two terms again, both have an x in them, so I take that x out and leaves me 5 plus 4. Plus in my 20. But what's 5 plus 4? So I really get x squared plus 9x plus 20. Okay. Would you guys agree, just as we go through here, just real quick, and we'll reiterate this again when I'm done. Would you agree that these two numbers, right there, 5 and 4, they add to give me that 9?
They do.
And at the same time, do they multiply to give me that 20? Would you agree that this 3 and 2, they add to give me that 5 right there? And they multiply to give you that 6 right there? Okay. So let's do this last one with this is a little bit more abstract here because we don't have any numbers. But what's x times x? X squared. What's x times b? Just xb, right? Or you want to write as bx? That's I'm going to write as bx. And then what's a times x? AX. And then what's a times b? AB. Okay. So again, I'm going to look at these two things right there, and I can take out an x. And I have something like that. Now there's nothing, I'm not going to simplify this because I don't have anything, I don't know what a and b are to actually combine them to a third thing. Sure. But would this look, does this look like, so is this a right there the same as that a right there? They are identical, right? They're the same thing. Would the b right there be the same as that b right there? Okay, so they're the same, but when we're doing this, a and b represent numbers, right? And if I say A is 2, then it's a 2 here, and it's a 2 there. If I say B is 5, then it's a 5 here, and it's a 5 there, right? So this A right there is the same as that A right there. This B right here is the same as that B right there. So what are we doing with A and B right here? What's that operation? You're adding them. What's the operation that's happening here? You're multiplying. Okay? Now this relationship that I'm trying to show you between these objects about adding and multiplying is the foundation for how we factor these quadratics. Okay? We are going to take, so I'll give you some rules here. It says, therefore, when looking at anything on the form x squared plus bx plus c, the task is to identify two numbers that multiply together to give you this last term. Okay? So two numbers that multiply together to give you 20, or two numbers that multiply together to give you 6, or two numbers that multiply together to give you AB. But then they, at the same time, those two numbers add together to give you 5, or add together to give you this 9. Does that make sense? Because remember what we're doing. We're starting with this side, and we're going to try to get down to this side over here. Okay? But this relationship of these being the same numbers that multiply together give me 6, but add to give me 5, or multiply together give me 20, add to give me 9, that is the approach that we're going to use to be able to factor anything. Okay? Now, it gets tedious, it gets troublesome, the larger that C term becomes, which is your last term, it's your constant. You know, if it's 15, there's only so many numbers that multiply together to give me 15, right? But it's 1500, there are a lot of numbers that multiply together to give me 1500. Okay? So the bigger this number here is, the more troublesome this is. Okay? But I think if you remember back to Algebra 1, okay, remember this is my C term, this is my B term, this one right there is my A term. Okay? Back in Algebra 1, to figure out how you do this, you probably say, okay, I know I'm going to look for numbers that multiply together to give me 15. So maybe you made a little bit of a table. Okay, and you said, I'm going to take a number like 1, and I'm factoring. So I know 1 divides 15, right? So my other factor would be 15. I know 3 divides 15. And when 3 divides 15, I get 5 back, right? Okay. Are those the only numbers that divide 15? 1, 3, and 15, right? Those are the only numbers that divide it? Or 1, 5, 3, and 15. So those are my factors. I know 1 times 15 gives me this. 3 times 5 gives me this. What do they add to? What's 1 plus 15? 16. What's 3 plus 5? 8. Do you see that these two numbers multiply together to give me 15, but they also add to give me that 8 right there? Does that make sense? So that tells me that 3 and 5 are the numbers I'm going to use. And because this A right here is a 1, and that's why we do this series of questions first. When that's a 1, what you do is you write X and X like that in your parentheses. And then whatever those two factors you chose that multiplied together to give you 15 and added to give you 8, you put them right there and right there. And now that is the thing that is, we call that factored form of that right there. Okay? How can I check myself? Say again? Not solve it. Let's say I gave you, let's say I gave 100 as a number, and I told you that it was divisible by 2, and I asked you, what is that result when it's divisible by 2? You tell me what? 50. How could you know that 50 was the answer to that? 50 times 2 gets you back up to what? 100. If I get back up to 100, what I started with, I know I've done this correctly, right? So if I just divided, that's what this essentially is saying. We just divided this thing here and found its factors, the things that multiply together to get this. So if I distribute this, if I FOIL this back out, what's x times x? X squared. What's x times 5? 5x. And then what's 3 times x? 3x. What's 3 times 5? 15. What happens to those two things right there? They make what? 8x. Is that what I started with? Yeah. So I know that that blue statement is exactly what we're looking for. Okay. Now, we're going to spend some time doing example after example after example of this because it's important. But I want to show you where this is going to lead to, because it's very important for us to be able to do this. A lot of the rest of the course is going to involve factoring. Okay. So our end goal eventually is to be able to graph x squared plus 8x plus 15 quickly. Okay. So right now, if I have x plus 3 and x plus 5, there we go, x squared plus 8x plus 15. Okay, that's the parabola that I get when we graph x squared plus 8x plus 15. If we're to graph it as x plus 3, x plus 5, that way, it's still the same thing. Okay, but what I'm going to do here is I'm going to zoom in right here. I'm going to look at these x values. One is -5 and one is -3. -5 and -3. Those places where that graph crosses the x-axis, that -5 and that -3 come directly from these two things right there. Okay? And if we can do this factoring, and I'm not going to talk about, it'll be the next couple sections that we see how x plus 3 turns into -3 and how x plus 5 turns into -5. But we're going to use this blue statement to factor, or not to factor, but to graph this original statement. So we need to be able to factor this original. Is that okay with everybody? Okay. Now, depending on how good you are at knowing your factors, essentially how good are you at division, you may have to develop, do a little scratch work on the side in determining which two numbers multiply together to give me 24 and that give me -11. I'll give you some hints here in a minute, give you some techniques that might be useful if you've got a calculator. But the time frame that takes you to do this compared to your neighbor might be different. And the only way that you get better at it is that you see more and more of them. Okay, but I'm even a person, and I've been doing this a lot longer than you have, right? I'll even come across a couple every once in a while where I've got to go to the side and I've got to actually write down some numbers that I know multiply together to give me this term and add to give me that one. Okay, you got to pay attention to signs as well. So when I look at this one, I'm looking for numbers that multiply together to give me positive 24. Okay, so what are some numbers that multiply together to give me 24? Okay, I'm gonna go systematically. I want 8 and 3 work. Okay, but 1 and 24. What's another set? 2 and 12. 3 and 8. 4 and 6. Okay, and then once I get past 4 and 6, they start repeating in the opposite order, right? They go 6 and 4, 8 and 3, 12 and 2. Okay, so if I add any of these, if I add those, I get 25. I get 14, 11, and 10. Which one of these do I use? Okay, so those give me 11.
It's tricky though, 'cause that's negative.
But this was -11.
Gotta be safe.
Well, think about this. If they're both negative, what's -3 times -8? Times.
Oh, times -1. No, wait, what are you asking?
So -3 times -8. What's a negative times a negative?
Positive.
Positive, and so I get 24, right? So with them both being negative, I get that positive 24. What's -3 plus -8? -11. So we wrote our factors out, but they both actually have to be negative for us to get that positive and that to be negative when we add them. Okay, so you got to pay attention to the signs when we're doing this. So when I factor this, it's going to be x, and I put my -3 in, and then x, and I put my -8 in. And that is then the exact same thing. It's a different format, but it's the exact same thing as x squared minus 11x plus 24. As we work through this stuff, so you did a little bit of this in Algebra 1, okay? Doing it again here in Algebra 2. When we do little things like this in Algebra 1 and Algebra 2, you might not recognize ultimately why we're doing this. Okay, I try to give you a little insights, like, we're going to graph these eventually, so that's the purpose of factoring, okay, and getting this x minus 3 and x minus 8. But those two, the green one and the blue one I just highlighted, they both have uses, okay? I'm not going to say one is better than the other, okay? This one actually tells me where the graph crosses the x-axis. This one tells me where the graph crosses the y-axis. Okay, they both have a use. Okay, in a lot of things in real life, you might be asking, why are we talking about parabolas? Why do we care about these things? Okay, if you are to take any projectile, okay, whether you're kicking it, throwing it, firing it, launching it, whatever, okay, its path that it takes is a parabola. Okay, so if I throw my marker, that path it just took was a parabola. Does that make sense? No matter how hard I throw it, no matter where I let it go from, it's going to travel a path of a parabola. Okay, have you guys ever played this game where I've got like a mountain here, and then over here is another mountain, and there's like a tank here and a tank over here?
Oh, yeah.
And you have to like change the angle of your cannon and you fire something and then it like breaks off here and your tank falls or whatever, and then this one gets a chance to go. Okay, you've ever played that game? Okay, so I don't know. But that is being programmed by parabolas. Okay, that's how we do that stuff. If ever I shoot a ballistic, its course is parabolic. Okay, does that make sense? Okay. If I throw a baseball from pitcher's mound, okay, the path that it takes, you might think it's linear, but the path that it actually takes is parabolic. Okay. So that, I mean, there are huge real life applications of this stuff, but we can't get to these real life applications until we understand the kind of the arithmetic of doing it, okay, of getting that stuff. So take a minute and do this next one. See what you come up with. All right, so if I want to find my factors using Excel, okay, what I'm going to do is I'm just going to type in, let's see here. I'm going to type in 1, 2, 3. So I set up a pattern here, okay? And then I can click on that I can click on those, and I can drag that down as far as I need to. Okay, and it just repeats those numbers. It keeps counting them, okay? Now, I can then say in this column here, see if I can set this up the best way for you guys. Do you guys, let's do this. Do you guys have this calculator on your computer still?
No, it won't, like, I go click on it and it won't load. So then
Mine never
download
even
something,
worked
and then
last
I
year.
can't download
Okay, so let's do that. Let's get this. Let's get this thing opened up. I'll show you how to get the stuff so it works. So it does this. Is that what you're saying? Yes? No?
I never opened it.
Yeah, and then you have to.
Okay, so where we go to find this, what they're calling a ROM, you go down here, you go to your File Explorer, which is this thing, right? You're going to go find the K drive. Okay, so this is all on video right now, so you guys can come back and look at this later. But you go to the K drive, and you're going to go to, where's the, it should say something about high school. You see where it says high school textbook? Where's that at?
Textbook high school, down.
Okay, textbook high school, double click there. And then you're going to go to, should say math somewhere, go to math. And then you see where it says math calculator? Okay, so it gets here. So if you don't have the actual icon on your desktop, going through those steps, you can get to this, and that's the executive file. So you can double click that, and it'll run, and it'll put it on your desktop. But then you've got to take one of these. Okay, the SE ROM is the newer one. So all you got to do is you take that, and you drag it to your desktop.
That's 2015.
Okay, so you drag it to your desktop. Okay, now that's on my desktop. When this comes up and it says browse for a ROM image on my computer, hit browse. And then you just got to find it on your desktop. So you got to go find your desktop right there. You see how that ROM right there? I double click on that, and it automatically then links that directory. Hit finish, and it should show up. Okay. Now I believe once you get it to your desktop, you can take this and drag this on top of Wabbit EMU, and it'll open up that way. Okay. So the way that we use this to find our factors, and I'll see if we can do the same thing on Desmos. I don't know right off the bat whether Desmos can allow me to find my factors real well or not. But basically what you do in here is you hit y equals. Okay. And now let's say that I want factors of, give me a number. 70. Okay. So let's go to like 74. Factors of 74. Okay. So I type in 74, and I'll hit divide X. Okay. And then we're going to hit second table. Okay. And it's going to now tell me right here, those two numbers multiply together give me 74. These two numbers multiply together give me 74. Okay. Those do as well, but that's not a whole number, right? So those won't be anything that works. So these are only two that will work for 74. If I wanted, let's go, what do? We did 24 a minute ago, right? So type in 24 there. And I go second table. And then you see 1 and 24, there's 2 and 12, there's my 3 and 8, there's my 4 and 6. And then we just have to decide, okay, which of those add to the number that we're looking for. Does that make sense?
What if there isn't?
Okay. Then if there isn't one, at the moment, we just say we can't do this problem. Okay, huh? Yeah, but so the question is, let's say that I give you something like x squared plus 7x plus 9. The only thing that multiply together give me 9 are 1 and 9 or 3 and 3, right? In any format, positive or negative, none of those add up to 7. So what we do is we say, right now, this is prime, meaning that there's not factors right now that we are aware of that will divide x squared plus 7x plus 9. Eventually, I'll give you a tool. Have you guys ever seen this? Algebra 1, not a protractor. Have you seen this before? Never seen that? Okay, that is what you will use when there's not numbers that multiply together to give me 9 and add to give me 7. This will find them, okay? And what that's going to do is it's going to find those numbers in here that may have been like the 5 and 4.8. They would have been non-integer values. So we will continue working on this stuff in the next couple days. My plan is to go somewhat slow with this because of how important it is later on for not just this class but other math classes. Oh, thank you. Yes.
Friday, 'cause I got